enter into this section. If you haven't watched the video for the video right before this one, I would suggest that you do so because I kind of explained this a little bit more. But this is essentially what we're doing today. So if you don't have this written down, then I would pause the video right now so you can get this copied, and then we'll actually do some of the examples together. Okay. Here we go. So, example 1. We're going to graph y equals 2 times log base 3 of x plus 2 minus 4. Alright, now in graphing this, we're going to do the same steps kind of that we did for exponentials. First thing we're going to do is label the transformation. So we're going to go left 2 and down 4, because here's my h and my k. They do the same thing here for logs that they did for exponentials. And then I'm going to make my small table of values. Now, with logarithms, because they grow so slowly over time, we're going to use 1 and 10 because otherwise my y values aren't going to be much different and I'm not going to be able to see the graph clearly. Alright, draw the brackets around the y and the x. Now, this is a little tricky part. When you have to plug in 1 and 10, what you're doing is you are actually using the change of base formula. Which, keep in mind, the change of base formula, which is on the previous side, looks like this. ln of x over ln of b. So, when I need to punch out log base 3 of 1, and I'm actually going to write this out, this is how you punch it into the calculator. Okay, and so if I do that, 2 times ln of 1 divided by ln of 3 gives me 0. Then I get 2 log base 3 of 10 equals 2 times ln of 10 over ln of 3. So 2 times ln of 10 divided by ln of 3 gives me 4.19. So these are the 2 points that I'm going to plot. 1, 0. Oops. 1, 0. And then 10, 4.9. 1, 2, 3, 4. Each one of those points has to shift left 2 and down 4. And the other thing to keep in mind too is logs are opposites of exponentials. So exponentials have a horizontal asymptote that they follow. Logarithms have a vertical one. Now the vertical asymptote is always at the y-axis until you shift left or right. So because I shifted left 2, I'm going to have to draw my asymptote at x equals 2, and then I can follow that up until it hits my curve. Hits my point. Okay. With exponentials, my domain was all reals, and my range was affected by where the asymptote is. Here it flips. I can plug in most numbers that I want. So my domain, not my domain, my range here is going to be all reals because I'm growing, and so every y value eventually will be able to be hit. So range is all reals. Domain is affected because my graph can't start until that asymptote starts. So the asymptote shifted left 2, so my domain is going to be x values that are greater than -2. Anything to the right of that. Okay, example 2. Okay, same type of deal here. Label transformation, so I'm going to go left 2, up 1. Make my small table of values. When I plug 1 in, log base 7 of 1 equals ln of 1 over ln of 7, which equals 0. By the way, that will always happen. And then log base say 7 out of 10. Excuse me. Ln of 10 over ln of 7, which equals 1.18. So I'm going to go ahead and plot those. And then we're going to shift those left 2, down 1. And then because everything shifted left or right, it has to also shift left 2. And the graph will follow your points. Domain range. Domain, our x-value is greater than -2 again, because your whole graph is on the left-hand side. And then your range is going to be y-value, your range is always going to be all reals. Because it will eventually cover every y-value if it continues towards infinity. Okay. And last example for today on graphing. Actually, you know what? I'm going to change this one. Okay. Same thing. My transformations are right 1, up 3. Small table of values. Now here, because you have an ln and not a log base whatever, you can just use the ln on your calculator to figure it out. This should be 0. And then we have -2 ln 10. 4.605. Okay, we'll plot those two. Then go right 1 and up 3. And then because my graph shifted to the right 1, my asymptote is also going to have shifted right 1. Draw my graph. Domain and range. Range is all reals with logarithms because you're going to eventually hit every y value. The domain here is going to be x values greater than 1 because the whole graph is to the right-hand side of 1. Okay, so we will work on that a little bit more tomorrow. This is Crisscross signing off.